In this video, we're going to take a look at another type of confidence interval question. And this is when you've got a larger sample. And what happens when they give you a larger sample is they're not going to give you like all the numbers because that'll be too time consuming. They will give you like the summary data instead. And if they do give you the summary data, don't be scared, don't worry, just look in the formula booklet. And in the formula booklet, there's two different ways that we can calculate. The S, now don't forget S represents the sample standard deviation. Like we've taken a sample of 50 and we're going to calculate the sample standard deviation. Now if you look at the formula that we've been using, obviously there's sigma there, but don't worry because like if the sample's large, and when we say large in statistics, we mean like over 30. So if the sample's large, if it's over 30, the standard deviation that we're going to get, we can just use the same as the sample standard deviation. Say, look, it's accurately going to represent the population standard deviation. So all we've got to do is, if they do give us this summary data, calculate the sample standard deviation and then use it there. Okay, because obviously they won't give you the standard deviation in the question. If they give you the standard deviation in the question, don't worry about it, just use the one that they give you. But if they don't give it to you, we've got to calculate it. Okay, so the call times for the fire station, we've got a random sample of 50 occasions. We're also told it's a random sample, so we don't need to assume that, which is nice. Okay, we're not told that the distribution, the data, the times are normally distributed. But we don't need to on this question because if the sample's large, we're allowed to just use the normal distribution anyway. Okay, again, we won't go into that too much in detail until next year, but for now, just realise that if the sample's small, we have to assume that the data is taken from a normal distribution. If the sample's large, it doesn't matter, we can still use the normal distribution. And we will use the sample to estimate the standard deviation. So we're asked to construct a 99% confidence interval. So first of all, let's get the sample mean. So the sum of x over n. Sample standard deviation. Now, there's two versions of this formula, but we're given this sum of x minus x bar squared. So I'm going to use this formula. Sum of x minus x bar squared would be 45.16 divided by n, which is 50. Okay, so I've got 5.73 for the sample mean and 0.9504. Notice I'm still maintaining some accuracy in this calculation. You might want to do maybe 3.7, at least 4 significant figures. Now that we've done that, we can calculate our confidence interval. So the confidence interval is the sample mean plus or minus the z value, which I'll get in a second, times by the standard deviation divided by the square root of the sample size, which is 50. And then we go on to menu stats, distribution, normal, inverse normal, tail central, area 99%, so 0.99. And we're going to get 2.576. Okay, so now let's just tally this up to see what our interval is. So the amount that we're going to have to add on and subtract is 0.34623. And that's quite a small amount if you think about it. Like the reason why we don't have to add much on and take much off, there's two things. The sample that we've taken is quite large and the standard deviation as well is quite small. So if the standard deviation is small, there's not much variation in the results. Okay, so we can be fairly confident in our answer. And also the fact that the sample was large, it gives us, divided by this larger value, gives us a more confident answer. not a more confident answer, sorry, we're still going to be 99% confident, but a more, you know, closely grouped answer, a more accurate answer. So we've got 5.73. So we've got 6.076. Okay. So remember, we are 99% sure that the average time, okay, it doesn't tell us about the individual times, don't forget, this tells us the average time is going to be somewhere in between these two numbers. Okay, I've just noticed actually that I did A and B together. So part C, it says the fire and rescue service claims that the mean call out time. So don't forget, if it asks you about the average, we can use our confidence interval. If it asks you about like an individual time, you can't use your confidence interval. Okay, so the fire and rescue service claims that the mean call out time is less than 5 minutes. A parish councillor suggests that it's more than 6.5 minutes. So if you look at our confidence interval, would we agree with the fire and rescue service? They're saying that the average call out time is less than 5 minutes. Well, we think the average is somewhere in here. And it's definitely not going to be less than 5. It looks like it's more than 5. It looks like it's somewhere between 5 and 6, doesn't it? So to comment on this claim, use the numerical values. Like you've got to, when you're commenting in statistics, use the numbers in the questions, use the context. Okay? So I would say, well, 5 is less than 5.384. So claim mean. What's the variable? What we're looking at? Time. Okay, use the word mean, use the variable, the word time, and never write like a definite statement. I was going to say is invalid, but I'm going to say the claim the mean is less than 5 appears invalid. You could also say it's not, the claim is not supported by our confidence interval, but a good way of looking for it is invalid. So it shows that you disagree with the claim. Parish council suggests that the average is more than 6.5 minutes. Well, I disagree with him as well. Like sometimes we will agree, by the way. Like if I would have said, for example, Josh claims that the average time is 5.5 minutes. If it had said 5.5 minutes, that would lie within the interval, in which case you would agree with Josh's claim. And you just write it in between and say it's in the interval, agree with the claim. But in this case, I disagree with that claim as well. Okay, so again, just be really thorough in your comments, use the context. Okay, last part of the question. It just says, state the probability that the confidence interval does not contain mu. Remember, mu is like the actual mean, like the population mean. We've taken a sample. Our sample mean was 5.73. We've added a bit on, we've taken a bit off. But the actual mean, the population mean, now it says state as well. When it says the word state, you know, you're not going to have to calculate anything. If you've got a 99% confidence interval, the chance that you're wrong, in other words, that, say if that was our interval and the actual mean was somewhere over there, like this could happen in two ways. Like imagine if the sample mean that we'd taken, if our sample mean was too small or if our sample mean was too large, and when we add a bit on we take a bit off, the actual mean that we're looking for was not contained. There's a really small chance it would happen, and like if you're doing a 99% confidence interval, you're 99% sure that the mean's in there. So the chance that you're wrong, or the chance that it's not in there, 1% chance. Okay, thanks guys.